Today we want to talk about introduction to physics, and this is a very important introduction for you as a student who is taking physics, and maybe you would want to be a pilot and an engineer, in the future. So physics is very broad, and we also do advise that. And with time, you will discover a lot. So this is the first topic in physics, that is Cambridge all level topic 1, that is motion, forces and energy. Motion, forces and energy. Now we start by the first sub topic of forces, motion and energy, and the first subtopic is 0.1, that is physical quantities and measurement techniques. So under this subtopic, you should be able to understand that in physics, we are more focused in one, the length, the mass, and time. So these are the main basic quantities that we are going to talk about in this tutorial. Then we'll go about the powers of 10 shorthands. Thereafter, we'll talk about length, talk about the subunits of length, multiples for large distance, then probably show you the diagram showing how to measure length using ruler. Thereafter, I will wrap this and continue with the notes to significant figures. Now, as a student, this is very important on your side, that you need to understand that, for example, you want to be a pilot. For instance, physics do play a key role in piloting. Then you also need to understand that for physics, we are concerned with one, the principles. We are concerned about the principles. After that, we are also concerned about the SI units. We are concerned about the SI units. Apart from the SI units, we are concerned about the physical quantities that we are starting about. We are starting with physical quantities. After that, now there are now questions that you will deal with. That's all about calculations. Whenever you are asked about calculation or you are given a question to do that, you need to calculate. First of all, you have to tell us the formula. So you need to first write the formula. Number 2, you will need to show us the procedure. Then lastly, you need to give us the answer. A point to note when answering is, after you've given out the value of the answer, it must be accompanied by the SI unit. It must be accompanied by the SI unit. If you are not sure about the SI unit, please do not write a wrong SI unit, because you will miss a mark on that. You better leave the answer without the SI unit, or you should write the SI unit. So those are the basic principles that you will be able to understand in the physics classes. And now let's dive into what we are learning today. We are starting with the units and the basic quantities. We are starting with the units and the basic quantities. So three basic quantities that we measure are length, mass, and time. These are the major quantities that we use in physics. And you note that units for other quantities are based on them. For example, length is a unit and it is measured in meters. So from meters itself, we are able to find area, we are able to find volume, and any other units. Let's talk about density. Density itself is given as, so density as rho is equals to mass over the volume. You'll agree with me that density has already have a basis on mass, and it also has a basis on length, which is length is now given as a cube, that is volume. Even pressure, we'll talk about all these with time, which is equals to force over the area. You'll agree with me that force has a basis of mass times g, and then the area has a basis of length, which is meters. So that's why we are saying that the basic quantities that we will be even discussing about here are just three, which are mass, length, and time. Good. Let's see. The SI unit system, that is an international system that is used to give the units of every particular quantities like length, like mass, like volume, like pressure. So they are SI units. So the SI unit system is which units are divided or multiplied by 10 to give smaller or large units. So those are the SI units. We're just trying to define what an SI unit will stand for. So it's a system in which units are divided or multiplied by 10 to give smaller or large units. Point 2 is measuring instruments on the flight deck of a passenger jet provides the crew with information about the performance of the aircraft. That's why I'm saying that if you're a student with a passion in piloting, and we know that piloting, we also give the advice on every career that a student take. So piloting is key for mathematics and physics. So when you're doing piloting, at the flight deck, that is the front face of after the cockpit, the front space, you will be able to see the various instruments that are used to measure either the altitude, the temperature, how to take off the plane, how to land, how should the plane sink or should the plane decline while landing or taking off. So we use physics to give those units that helps the pilot for the aircraft. And again, we advise of the same as Bright Star Tuition. So powers of 10 shorthands. Powers of 10 shorthands. You're saying that physics calculations, you might get answer which is small, answer which averagely normal, or answers which are big. But I'm trying to tell you that most of the answers for physics are always given in power, in significant figures form. Like for example, so if you're talking about the powers of 10 shorthands, yeah, we're just talking about numbers which are rewritten as significant figures. And so they would take a value of a less than or equals, I mean 1 less than or equal, a value between 1 and 9, then multiply by the power of 10. So this is a neat way of writing numbers, especially if they are large or small. And I've given examples here, and you're saying that instead of just writing your answers as 4,000, give your answer in standard form. And now 4,000 can be rewritten in a standard form of 4 times 10 power 3. 400 can be written in a standard form of 4 times 10 power 2. And then 40 can be written in a standard form of 40 times 10 power 1. Then 4 can be written in a standard form of 4 times 1 equals, which is 4 times 10 power 0. And remember that any value raised to power 0 is always 1. So 10 power 0 is the same as 1, and 1 times any other number is just but that number. Now that up to here we have the positive powers, that is 1, 2, 3, and blah blah. But we can also have negative standard forms, that is in power. Like 0.4 is the same as 4 times 10 power negative 1. 0.04 is the same as 4 times 10 power negative 2. 0.004 is the same as 4 times 10 power negative 3. Now, I've given a note here, and I'm saying that the small numbers, which are 1, 2, 3, negative 1, negative 2, and negative 3, are powers of tens. So the powers shows how many times the number has to be multiplied by 10 if the power is greater than 0, or divided by 10 if the power is less than 0. Good. So this way of writing is called standard notation. That's why I'm saying, and write this. This is what we call standard form or standard notation. That all ways of writing. If you give your answers in this, if you leave your answer like this, those are all standard form. Let us go to something else. And that is length. And I've defined length as the distance that is traveled by light in a vacuum during a specific time interval. Now, before we knew length, and we still know length as the difference between 2 points. So if you move from point A to point B, you're covering a distance, and you're covering like a length, or rather, length is like a distance of between 2 points. And here we are telling you that this is a distance which is traveled by light in a vacuum during a specific time interval. That's like a scientific definition of length. And the SI unit of length is meters. So you can see here that I have an SI unit of length as meters. And then we are showing you that we do not just have meters, but that is the main length we are using. We can still convert meters into decimeter, into centimeter, into millimeter, micrometer, and even nanometer. You can even go to more big units or great units like kilometer, gigameter, and I've given you the relationship between decimeter to meter, which is 1 decimeter is the same as 10 power negative 1 meters, and 1 centimeter is the same as 10 power negative 2, and again 1 millimeter is the same as 10 power 3 meters, 1 micrometer is the same as 10 power 6 meters, 1 nanometer is the same as 10 power 9 meters, 1, and then we have the multiples for larger distances, which are 1 kilometer is the same as 10 power 3, that is 10 cube meters, and 1 kilometer is the same as 5/8 mile, or 10,000 meters is the same as 5/8 miles, that is in terms of miles. Then we have 1 gigameter, that is the unit for gigameter, which is the same as 10 power 9 meters. Then the most measurements which are made are in rulers. So we do measurements most in rulers, and they are shown like this diagram. And basically what this diagram shows us is, if you want to do a measurement using a ruler, the view of the eye should always be perpendicular to the horizontal. So it should be vertical, not this way. So if you can see here, this is a bit bending, and now it will give an inaccurate answer, but this is vertical. So like this is 75 centimeter if you look it vertically, but if you put your eye in wrong position like this one, you will get it as 76 meters, like example in that diagram. And then finally we are saying that to obtain an average value for a small distance, multiples can be done, or rather be measured. For example, the ripple tank, you know about the ripple tank? And the ripple tank, in its experiment, we measure the distance which is occupied by the 5 waves. If you do the distance occupied by the 5 waves, then you divide them by 5, you should be able to get the average, which is the wavelength. So wavelength is also given as this. So this is the first subtopic, and we are still continuing with it. From length, we're going to discuss about significant figures, down the topic. After that, now what I'm doing here is basically what we are doing in real tuitioning, that is homeschooling and blended learning, where if the students still cannot understand, we do the video for the same course like this, and we provide them with a student for better understanding, so they can repeat and go through it again, until now they are able to understand. And I'll wrap this so I can do significant